AlphaEarth Foundations, mapping our planet with AI. Imagine having a virtual satellite that can map our entire planet in unprecedented detail, providing scientists and experts with a nearly real-time view of our world. This is now a reality, thanks to AlphaEarth Foundations, a revolutionary artificial intelligence AI model that integrates petabytes of Earth observation data to generate a unified digital representation of our planet. But here's where it gets really exciting. This technology has the potential to transform the way we understand and interact with our planet, from monitoring climate change to optimizing food production. Every day, satellites capture vast amounts of information-rich images and measurements, offering a unique perspective on our planet's dynamics. However, the complexity, multimodality, and rapid refresh rate of this data create a significant challenge. Connecting disparate datasets and making effective use of them all. This is where AlphaEarth Foundations comes in, an AI model that functions like a virtual satellite, accurately and efficiently characterizing the planet's entire terrestrial land and coastal waters by integrating huge amounts of Earth observation data into a unified digital representation, or embedding, that computer systems can easily process. This allows the model to provide scientists with a more complete and consistent picture of our planet's evolution, enabling them to make more informed decisions on critical issues like food security, deforestation, urban expansion, and water resources. And this is the part most people miss: the potential for this technology to democratize access to geospatial data, enabling organizations and individuals around the world to create custom maps and drive real-world insights. To accelerate research and unlock use cases, the AlphaEarth Foundations team is releasing a collection of annual embeddings as the Satellite Embedding dataset in Google Earth Engine. Over the past year, they've been working with over 50 organizations to test this dataset on their real-world applications, and the results are astounding. Partners are already seeing significant benefits, using the data to better classify unmapped ecosystems, understand agricultural and environmental changes, and greatly increase the accuracy and speed of their mapping work. But how does AlphaEarth Foundations actually work? The model provides a powerful new lens for understanding our planet by solving two major challenges: data overload and inconsistent information. First, it combines volumes of information from dozens of different public sources: optical satellite images, radar, 3D laser mapping, climate simulations, and more. It weaves all this information together to analyze the world's land and coastal waters in sharp 10 by 10 meter squares, allowing it to track changes over time with remarkable precision. Second, it makes this data practical to use. The system's key innovation is its ability to create a highly compact summary for each square, requiring 16 times less storage space than those produced by other AI systems and dramatically reducing the cost of planetary-scale analysis. This breakthrough enables scientists to do something that was impossible until now: create detailed, consistent maps of our world on demand. Whether they are monitoring crop health, tracking deforestation, or observing new construction, they no longer have to rely on a single satellite passing overhead. They now have a new kind of foundation for geospatial data. But here's the controversy. Will this technology exacerbate existing power imbalances, or will it democratize access to geospatial data and create new opportunities for marginalized communities? We'd love to hear your thoughts in the comments. To ensure AlphaEarth Foundations was ready for real-world use, the team rigorously tested its performance. When compared against both traditional methods and other AI mapping systems, AlphaEarth Foundations was consistently the most accurate. It excelled at a wide range of tasks over different time periods, including identifying land use and estimating surface properties. Crucially, it achieved this in scenarios when label data was scarce. On average, AlphaEarth Foundations had a 24% lower error rate than the models tested, demonstrating its superior learning efficiency. The Satellite Embedding dataset powered by AlphaEarth Foundations is one of the largest of its kind, with over 1.4 trillion embedding footprints per year. This collection of annual embeddings is already being used by organizations around the world, including the United Nations Food and Agriculture Organization, Harvard Forest, Group on Earth Observations, Map Biomas, Oregon State University, the Spatial Informatics Group, and Stanford University, to create powerful custom maps that drive real-world insights. For example, the Global Ecosystems Atlas Initiative is using this dataset to help countries classify unmapped ecosystems into categories like coastal shrublands and hyper-arid deserts. This first-of-its-kind resource will play a critical role in helping countries better prioritize conservation areas, optimize restoration efforts, and combat the loss of biodiversity. As Tasso Azevedo, founder of Map Biomas, said, "The satellite embedding dataset can transform the way our team works. We now have new options to make maps that are more accurate, precise, and fast to produce, something we would have never been able to do before." But what does the future hold for AlphaEarth Foundations? The team is currently exploring the best ways to apply the model's time-based capabilities as part of Google Earth AI, a collection of geospatial models and datasets to help tackle the planet's most critical needs. They believe that AlphaEarth Foundations could be even more useful in the future when combined with general reasoning LLM agents like Gemini. As we look to the future, we're left with more questions than answers. Will AlphaEarth Foundations revolutionize the way we interact with our planet, or will it create new challenges and complexities? How will this technology impact marginalized communities, and what are the potential risks and benefits of democratizing access to geospatial data? We'd love to hear your thoughts and spark a conversation in the comments below. To learn more about AlphaEarth Foundations, you can read the team's paper, access the Satellite Embedding dataset, or learn more on the Google Earth Engine blog. This work was a collaboration between teams at Google DeepMind and Google Earth Engine, and we're excited to see the impact it will have on our understanding of our planet and its dynamics. Revolutionary AI maps Earth in unprecedented detail. AlphaEarth Foundations. Imagine having a virtual satellite that can map the entire Earth in unprecedented detail. That's now a reality. A groundbreaking AI model has been unveiled, capable of mapping our planet with a level of precision and speed that was previously unimaginable. This innovation has the potential to revolutionize the way we track climate change, monitor environmental issues, and make informed decisions about our planet's future. Developed by Google DeepMind, the AlphaEarth Foundation system harnesses the power of artificial intelligence to analyze vast amounts of observation data, creating a highly detailed and accurate picture of the Earth's terrestrial land and coastal waters. To put this into perspective, the system uses petabytes of data, equivalent to 1,000 terabytes, or around 1,000,000 gigabytes. That's roughly the same amount of data stored on 20,000 Blu-ray discs. But here's where it gets really exciting. This technology enables scientists to create detailed, consistent maps of our world on demand without relying on a single satellite passing overhead. Whether they're monitoring crop health, tracking deforestation, or observing new construction, researchers now have a powerful tool at their disposal. The AlphaEarth Foundation system functions like a virtual satellite, integrating data from dozens of public sources, including optical satellite images, radar, 3D laser mapping, and climate simulations. This unified digital representation or embedding can be easily processed by computer systems, allowing researchers to analyze land and coastal waters across the globe in 10 by 10 meter squares. But what really sets this system apart is its ability to create highly compact summaries for each square of data. These summaries require 16 times less storage space than those produced by other AI systems, dramatically reducing the cost of planetary scale analysis. And this is the part most people miss. The AlphaEarth Foundation system has been consistently shown to be the most accurate when compared to traditional methods and other AI mapping systems. It excelled at a range of tasks over various time periods, from identifying land use to estimating surface properties. Crucially, it achieved this in scenarios when label data was scarce, demonstrating its superior learning efficiency. According to a study detailing the new system, AlphaEarth Foundations had an average error rate of around 24% lower than the other models tested. This level of accuracy has significant implications for researchers and policymakers, who can now make more informed decisions about critical issues like food security, deforestation, urban expansion, and water resources. DeepMind has also released a collection of annual embeddings from AlphaEarth Foundations as the Satellite Embedding dataset in Google Earth Engine, a cloud-based geospatial analysis platform. The dataset is among the largest of its kind, with over 1.4 trillion embedding footprints per year. But what does this mean for the future of our planet? As new measurement platforms are launched and others decommissioned, the accelerating pace of observational data collection pushes forward. It's critical that we support the community of applied scientists and practitioners deriving insights about our planet that inform decision-making and policy action. Several organizations across the globe, including the United Nations Food and Agriculture Organization, Harvard Forest, Group on Earth Observations, Map Biomas, Oregon State University, the Spatial Informatics Group, and Stanford University, have already been using this dataset to create detailed custom maps. As we move forward, it's essential that we consider the implications of this technology. Can we balance the need for accurate data with concerns about surveillance and data privacy? How will this technology be used to inform policy decisions? And what are the potential consequences of relying on AI-generated maps? We want to hear from you. Do you have thoughts on the potential applications and implications of this technology? Share your comments and let's start a conversation about the future of our planet.